Alright, we're going to start 6.6, solving polynomial equations by factoring. So the first thing we need to know about this section is we need to know about the zero product property. The zero product property. So this is what the zero product property says. It basically says if you have something times something else and this is equal to 0, then either one of those two numbers has to be 0, right? Either this has to be 0 or this has to be 0.
You said multiply or?
Multiply. No, multiply. Product. We're talking about a product. So the zero product property says if we're multiplying two factors, at least one of the factors has to be 0. They could both be 0, but at least one of them has to be 0 to get a product of 0. Okay? So the type of problems we're going to do in here is I'm going to give you a polynomial equation. And I'm going to say solve. I'll give you something like 3x squared plus 5x is equal to 14x. Okay, so to use the zero product property, the first thing we need to be able to do is we need to have 0 on one side of the equal sign. Right now we don't have 0 on one side of the equal sign, so we need to make one side 0. I'm going to move the negative, this 14x as a negative 14x to the other side.
You're doing this because you want to make this side 0?
I want to make this side 0, exactly.
And it's always going to be that side?
It can be any side.
Okay.
I could have moved the other two terms, but it would have been more work to move the 3x squared plus 5x to the other side than the 14x.
So our goal is to get one of the terms 0.
Yes, our goal is to make one of the sides of the equation equal to 0. All right, period. You want 0 on one side of the equal sign. So I'm going to put it on the right hand side. So we'll have 3x squared minus 9x is equal to 0. All right. Are there any questions so far? No, we're good. Okay, so now we are ready to factor. So I'm going to factor 3x squared minus 9x. First thing I always try to do in factoring is factor out the GCF. Is there a GCF?
Yeah.
Yes, 3x. I can factor out a 3x. And I'm left with what?
X minus 3.
Yes. So 3x times x minus 3. Now I'm going to set each factor equal to 0. We have three factors here. We have a 3, we have an x, and we have an x minus 3. So let's set each factor equal to 0. 3, I'm going to set it equal to 0, right? Because one of the factors has to be 0. That's what the zero product property says. So it's either got to be the 3, it's got to be the x, or it's got to be the x minus 3. So the first one, 3 equal to 0. Does that make sense? No. If I asked you to solve that equation, what would you say the answer is? It's like that. What's another way to say when something doesn't have an answer? This has no solution. When you end up with a false statement, no variables, there is no solution to this. So 3 equal to 0, I'm not even going to worry about that factor. I'm going to focus on the other two factors that actually have variables that can be solved. Next one, it's already solved. X equal to 0. That's one of the possible solutions. If x is equal to 0, I will get a product that's equal to 0. And the last one, I'm going to add 3 to both sides. I'm going to get x is equal to 3. So my solutions for this equation are going to be 0 and 3. And what do you do when you're done with one of these problems? You always check it. So let's go and check it and make sure that these answers both work. I'm going to use the original equation because just in case I made an arithmetic mistake or an algebraic mistake in any of my manipulations here, I will catch it in the check.
But I don't get how the last one solved. Isn't it supposed to equal 0 but ends up equaling 3?
If I substitute a 3 in for x, I get 0. 3 minus 3 is 0.
Oh, that's what it means.
Yeah,
Not
yes.
that x equals.
No. It says 3 minus
I
3.
mean, it does mean that x equals 3, so I just have to plug it in to see that.
Yes. Yes.
Okay.
Yes, Calvin.
I'm just curious, if we're going through and like you said, we do our checks. Let's say we do our computation, we're trying to buy time. If we do our check and we find a mistake, will you accept our check if we correct our mistake? If that makes any sense?
Yes, I will accept it. Yes. Are you going to be sure that the answer that you got the second time?
I know that you got.
Okay.
The reason why you
Yes.
wrong on our exams because you don't like my luck.
Yes, that's
so
fine.
You see it and you're like, oh, that's wrong, but then the check is right and then the answer is really right. Is that okay?
Yes, that's fine. Okay, so now we're going to substitute 0 and see if this comes out true. So this is going to give me 3 times 0 plus 5 times 0 is 0 and 14 times 0 is 0. So this is just 0 plus 0 is equal to 0. Is that true or false?
True.
That's true. That means this is the right answer. Let's check the 3. 3 times 3 squared plus 5 times 3 is equal to 14 times 3. This is 3 times 9 plus 15 is equal to, what's 14 times 3? 42. So 3 times 9 is 27, and 27 plus 15 is 42. So both of my solutions are correct. Questions? Okay, let's try another one. Funner one. Okay? I'm going to give you a trinomial. Let's call this problem A up here. We'll call this one problem B. I'm going to give you a trinomial. This one. 4k squared plus 9 is equal to negative 12k. Okay, why don't I give you guys a head start. You guys go ahead and solve it. Yes, add the 12k, set it equal to 0, and then factor. So, no, because they are not like terms. Step 1 is going to be set the equation equal to 0.
So it would just be like added to the equation. It wouldn't be added to the work.
Yes, it would just be added. It would just be like you're just going to tag it along that side.
Oh, 4k squared plus 12k.
Exactly, 4k squared plus 12k plus 9 equals 0. Now what do you do next? Okay, there is no GCF, so I heard yes, you do look for a GCF, but in this case there's no GCF. So Amber, what did you say? The magic X. We do the magic X because it's a trinomial. So here, if it's a trinomial, yes.
And what's the other way that we don't do the magic X?
If you notice that it's a special product, Remember I talked about special products last time in class? You have perfect square trinomials, you have the difference of two squares. So do you guys notice if this is a special product?
It's because of magic X.
So Calvin said yes, he noticed that this is a special product. Calvin, can you tell us what you noticed about this trinomial?
I noticed that on the two, when you have side one, for me,
Yeah.
you got these two sides, right? These two are, you can make square roots out of these two, right? Like 2 times 2, right?
Right.
And then for this one, what's the square root of 12?
Are you sure it's the 12 we're looking at, Calvin?
9, I'm sorry.
The 9.
So that's what.
So Calvin noticed that the 4k and the 9 are perfect squares. You can go straight, and you have to also check to make sure that that middle term is going to be 2 times the square root of the first term times the square root of the last term.
Can we also,
Is that when you do the FOIL method? Is that when you can actually do that when to make it easier for yourself?
That might work too. I'm not familiar with how to do it that way, but I'm going to do the magic X just to be on the safe side.
and can we do it the other way after the magic X?
Yes,
So I can write that down on my notes.
absolutely. So let's do the magic X first. The magic X says that if we have a trinomial of the form ax squared plus bx plus c, if we multiply a times c,
That's what I was going to ask you, if there was another way to identify it, since it's in the form AX squared plus BX.
yes, it's a trinomial. You can always use the magic X when it's a trinomial. So this is going to give me 36. I need two numbers that give me 36 if I multiply, and positive 12 if I add. Positive 36 if I multiply, and positive 12 if I add. What are those two numbers? 6 and 6. So these are going to be my magical numbers. I'm going to use these numbers to rewrite the middle term. So the middle term is going to be rewritten, instead of 12k, 6k plus 6k. Okay, yes, question.
So you moved it around
In descending order.
in order, and that way the 2 squared on the outside, is that?
Yes, so remember, I think I mentioned this last time. Whenever I'm working with a trinomial, I always like to write it in descending order first. So descending order makes it a lot easier, I think, to factor. All right, we're going to keep the first term the same, the 4k squared, and we're going to keep the last term the same, the 9, and now I'm going to do factoring by grouping. I'm going to group the first 2 terms, and I'm going to group the last 2 terms. What can we factor out of the first 2 terms? 2k. And I'm left with 2k plus 3. What can I factor out of the second 2 terms? 3. And if you didn't catch that this was a perfect square trinomial at the beginning, you should be catching it right now. Right. You could also write it like that.
We took out 2k because that's the factor out.
This is we took out the 2k because we're factoring out the GCF of 4k squared plus 6k. Yes.
So we didn't have the 12k with the 9 at the top of that?
No, because we can't add 12k with 9. They're not common. They're not like terms.
So we're not forgetting the 0, correct?
And we're not forgetting the 0. We're still not done with this problem, by the way. I'm going to just go ahead and erase the binomial squared that I had written here. Normally that's the way I write it if I'm just factoring, but since I'm solving an equation, I'm going to set each factor equal to 0, and I'm going to solve each individual factor here.
And you got rid of the 2k in front, right?
I got the 2k got factored out, and then when I factored out the common factor for the binomial, I factored out 2k plus 3 at 2k plus 3. This 2k in the front ended up back here, and this plus 3 ended up right here.
Oh, that's how it disappears?
Yes. Well, it doesn't disappear. It's kind of like we factored out the 2k plus 3, and then that's the factor that gets left over after we factor out the GCF of 2k plus 3. All right, let's solve this. So now I'm going to subtract 3 from both sides. I'll have 2k is equal to negative 3. Divide both sides by 2. I get k is equal to negative 3 halves. I'm going to subtract 3 from both sides over here, and I'm going to end up with exactly the same answer. You don't have to do this twice. You could just write a single answer of negative 3 halves. We got a repeated solution there of negative 3 halves, but you just need to write it down once.